Suppose we wish to solve the following problem. A particle moves according to the law x is equal to a, some number, times the sine of pi t, where x is the displacement and time is time. Find the distance traversed by the particle in 3 seconds. Okay, to start, let's write down what we actually know. We know that the position of the particle, x of t, is governed by a times the sine of omega t, where here we have pi of t. The reason I wrote omega is because in general, whenever you see a sine or a cosine, this number multiplying time can be written as omega. So in general, this is some omega, where here omega is known as the angular velocity or the angular frequency. It's known as either. And here, the reason that we care about what this omega is because we have the relation t, which is the period, is equal to 2 pi divided by omega. So here, this guy is the period, which is how long it takes for this x to go one complete rotation. And the reason I say rotation is because whenever we have a sine or a cosine, let's draw out what we actually have for position. So if we draw out an x and a y graph, this is time, this is x of t, and this guy will be a, and down here will be negative a. We have the following. The graph looks something like this. We have this thing goes up, and then down, and then up again. So this is what the sine graph looks like. And we know that here is t is equal to 0, and here is t is equal to the period. So that's how long it takes for this graph to go up, down, and back to where it started. Right? Because if this thing were to continue, it would look something like this, and it would just repeat what it was doing before. So here we know what the period is. That's one complete rotation. Okay. So now, what is our omega? Well, our omega is just going to be pi. Right? So omega for us is equal to pi. But that means, what is our period? It means that our period is equal to 2 pi divided by omega, which is pi. So this is equal to 2 seconds. So our period is 2 seconds. So we can actually say that this t is equal to 2 seconds. Okay, this guy here is t divided by, this is t is equal to capital T divided by 2. And the time step right here is t is equal to big T divided by 4. And similarly, this time step is t is equal to 3 times big T divided by 4. So just to reiterate what I'm saying, this is something that's true for all sine graphs. So the peak of one rotation occurs at the period divided by 4 seconds. When it hits 0 for the first time, after it leaves t is equal to 0, that occurs at half of the period. Then, when you travel to the minimum, when is x of t the minimum? This occurs at 3t over 4, and a full period has elapsed when the sine graph goes up, down, and back again. So what this means is, if we label each of these points, so this is point 1, this is point 2, this is point 3, 4, and 5. Okay, that means that at point 2 occurs at t is equal to big T divided by 4. I've just rewritten what I have here. But big T is equal to 2. So this is 2 divided by 4. So this graph reaches its maximum after 1/2 of a second. And what do we know about how far this particle, right? Because we're talking about a particle here. What do we know about how far the particle has moved when it goes from 1 to 2? Well, let's just see. At 1, what is the distance traveled? Delta D is equal to 0, right? Or let's say x at 0 is equal to 0. And at 2, x at t is equal to 1/2 is equal, well, let's just look. That is the maximum, right, which is a. So that occurs at the distance here is a. Okay. Then we see that delta D from 1 to 2, so delta D going from 1 to 2 is equal to x at 2 minus x at 1. But we just found what those two x values are. That's going to be x of 1/2, right, because that's x at 2, minus x at 0 seconds, because that's x at 1. And that's going to be a minus 0, which is equal to a. So all that I've really said here is that when the particle goes from 1 to 2, it travels a meters. So what that means is in 1/2 of a second, in 1/2 of a second, or a quarter of a cycle, right? Because a cycle goes up, down, and back. So that's 1/4 of a cycle, because this is 1/4, 2 quarters, 3 quarters, and 4 quarters. So in 1/4 of a cycle, we've traveled a distance a. Okay, and we care about what happens after 3 seconds, right? So we want to know, so the delta D after 1/2, after t is equal to 1/2 seconds, is equal to a. So what is delta D of t is equal to 6 seconds? I'm sorry, to 3 seconds. What is delta D at 3 seconds? Well, let's just look here. In 2 seconds, let's see how far it travels, right? So we go up, it travels a distance a. It goes back down to 0, travels another distance of a. So that's 2a that it's traveled. Then we go down from 3 to 4. That's from 0 to negative a. That's another a distance that this particle has traveled. So that's 1a, 2a, 3a. Then from 4 to 5 is 4a. That's only 2 seconds. So we see that for each 1/2 second, this travels a distance of a. So to find out how far we've gone, the distance traveled after 3 seconds, this should be 3 times the distance traveled in 1 second. Right? Just because in each second, in each 1/2 second, we travel a distance a. So further, we can say that this is 3 times 2 times the distance traveled in 1/2 a second. Right? This is just because how much does the particle travel in 1 second? Looking at the graph again, 1 second goes from 0 to 3. So it travels a distance a, and then another distance a back down to 0. So it's traveled a total distance of 2a, right? So since delta d is equal to, delta d at half a second is a, delta d for 1 whole second should be 2 times that of half a second. So plugging in for what we have, this is 3 times 2 times a. And that's because delta d for t is equal to half a second is a. So this should give us 6a. That is the total distance, not the displacement, but the total distance traveled in 3 seconds is 6a. And we can see that if we extend our picture. I want to clarify why this is, in fact, the correct answer, because this may have been a bit confusing. So, putting this photo that we have again, we can now extend our initial picture. So, getting rid of this blue for a second, and extending, we say that this guy goes up again, it goes up again, and back down. Okay, so here, the point here occurs at t is equal to t, which is 2 seconds, right? And then again, this guy right here, this occurs at t is equal to 5 over 4t. And here occurs at t is equal to t is equal to 3 over 2t, which is equal to 3 over 2 times 2 seconds, which is equal to 3 seconds. Okay, so this is actually the point where we want to verify how far we've gone. So if this is position 6 and this is position 7, we can now just count up how far we've gone. So using a highlighter, we saw before that this distance here, this is a. Travels a distance a to get here. Right? This is a. Then we get another a from here downwards. Changing colors again. Here downwards is another a. Right? And that's just because we go up to a position a, and then we have to travel a distance a back down to 0. And the same works when we go down from 0 to negative a. That's another a that we've traveled, because we go from 0 to negative a. Right? If you want to travel from your position 0 to a position negative 3, you have to travel 3 meters. Okay, then if we travel up but from 4 to 5, that's another a that we've traveled. And then going from 5 to 6, that's another a that we get. And then finally, if we travel from 6 down to 7, that's another a that we get. And then we've traveled 3 full seconds. So let's just count up how many a's we have. We have 1, 2, 3, 4, 5, 6. We have 6 a's. That means the total distance that we've traveled, d, for t is equal to 3 seconds. The total distance that we've traveled is equal to 6a. And that's just because we have 6 of these a's. And with that, I'll end the video. Thank you.